Hi everyone. Today in this session we'll see about the acid base balance. So the objectives are definition and physical chemical properties with the examples of acid and base, Arrhenius concept of acid and bases, Laurie-Frosted theory of acid and bases and the classification of it, differences between bases and alkali, acidity and basicity, monoprotonic and polyprotonic acids and bases, and the concept of acid base reaction, hydrogen ion concentration, ionization of water and buffer, and the value of solution. So what is acid and base? Acids is defined as a substance that releases protons or hydrogen ions. Bases, it's a substance that accepts protons or hydrogen ions. So also acids are a proton donor, that is H plus donor, and the bases are proton acceptor. So the example for acid will be HCl. It donates H plus ions and Cl minus, and for base NH3 plus, it accepts the proton as an acceptor and releases NH4 plus. So there are three common definitions for acids and bases. Lewis definition, the modern day definition of a Lewis acid as given by the IUPAC is a molecular entity which corresponding chemical species, that is an electron pair acceptor and therefore able to react with the Lewis base to form a Lewis adduct by sharing the electron pair furnished by the Lewis base. So Gilbert Lewis focused on the donation or acceptance of a pair of electrons during the reaction. So Lewis acid is a electron pair acceptor and the base will be the donor. So most general of all three definitions, acids don't even need a hydrogen. The Arrhenius states that acids are substances which increase the concentration of hydronium ions in a solution. So when acids produce hydrogen cations or hydronium ions when dissolved in the water, that is as HCl, we can it releases H plus Cl minus. The base produces hydroxide ions when dissolved in water. As an example, sodium hydroxide, it gives sodium plus ions with the OH minus ions. So only in aqueous solutions. The aqueous solutions are liquids that have molecules dissolved in water. So Arrhenius acids, any substance that releases H plus ions as the only positive ion in the aqueous solution. So HCl, which reacts with the water, it releases H3O plus and Cl minus, that is chloride ions. And the definition as Arrhenius in aqueous solution, the acids form hydronium ions. And as a basis form hydroxide ions, that is OH minus. When NH3, that is base, reacts with the water, it releases NH4 plus and hydronium ions. So next, Fronsted-Lowry definition, as an acid is a substance which can act as a proton donor. Most acids encountered in everyday life are aqueous solutions or can be dissolved in water, and these two definitions are most relevant as the reason why pH of acid is less than 7 is that the concentration of hydronium ions is greater than 10 to 7 moles per liter. So since the pH is defined as the negative logarithm of a concentration of hydronium ions by the Anderson's equation, thus the acids thus have pH of less than 7. So by the Bronsted-Lowry definition, any compound which can easily be deprotonated can be considered as an acid. So example includes alcohols and amines which contains oxygen and hydrogen bond or nitrogen and hydrogen bonds. So Fronsted-Lowry acid, a substance behave as an acid when it donates a proton to a base. So acids are proton donors. When acids reacts with water, hydronium ions are produced. So according to him, the base will be a substance behaves as a base when it accepts a proton from an acid. So the bases are proton acceptors. So when bases reacts with the water, it releases hydroxide ions. And the chemical properties of acids include it changes the color of a litmus from blue to red and converts color of methyl orange from orange or yellow to pink. And this acid turns the pink color of the phenolphthalein to colorless in the titration and also conduct electricity. Some acids are highly corrosive in nature, which means that they are corroid of rust metals and also produce H plus ions when mixed with the water, and it lost their acidity when mixed with a base. So in a neutralization, and the acids react with the carbonates and hydrogen carbonates to form a salt water and carbon dioxide gas. So they are classified on their basis of source, strength, concentration and presence of oxygen and its basicity. So different types of an acids are strong acids, weak acid, mineral acids and dilute acids, etc. So we'll see strong and weak acids here. Strong acids rapidly dissociate, usually completely, and releases the H plus ions in solution. Example HCl and H2SO4. So HCl, which releases H plus and Cl minus, and H2SO4 H plus plus SO4 minus. So the ions completely dissociates from the acid. In a solution of acid HCl, almost all the molecules dissociate and exist as H plus and Cl minus ions. So here the dissociation will be complete, and so the concentration of H plus is very high. So HCl is a strong acid. So when it comes to dissociation in a weak acid, it will be incomplete. Example carbonic acetic acid. So H2CO3, it gives H plus and bicarbonate, where the ions will be incomplete. A weak acid in a solution will ionize only partially, so the number of acid molecules existing in the ionized state is much less concentration of a H plus. So H plus will be less. And the chemical properties of bases, it can change the color of a litmus from red to blue, and bases lose their basicity when mixed with the acid, and they also conduct electricity. And the bases feel slippery or soapy. So some bases are great conductors of electricity. So bases like sodium hydroxide, potassium hydroxide, etc. are used as electrolytes. And here the alkalis are bases that produce hydroxyl ions when mixed with the water. So the pH will be ranges from 8 to 14. And the bases are classified on their strength, concentration and acidity. As the different kinds of acids are, the bases are strong base and weak base. So the difference between acids and bases, as based on pH, acid pH is less than 7, where base is greater than 7, and the acids taste sour and the base bitter, and acid react with the bases whereas base react with acids, and acids it's a donor of proton, and the base it's an acceptor of a proton, and it turns blue to red in case of acid, blue and red to blue in case of a base, and both are electrolytes as they conduct electricity in a solution. So the differences between alkali and the base, as in the last slide we saw difference between the acid and bases, here the base and the alkali. So the bases do not dissolve in water, but the alkali, here the bases that dissolve in water are called as alkali. So all bases are not alkali, where alkali and bases. So base it neutralizes the acid. Example zinc hydroxide and copper oxide, where the alkali it releases OH minus ions and accepts a proton. Example potassium hydroxide and sodium hydroxide. So we will see some points of alkali as it's a base and base that dissolves in water. It's very important to remember that not all the bases are alkali, but alkali is a base. So it's a basic that alkali earth metals or alkali metal. On adding alkali to acid, the pH of the mixture increases. So the basicity also increases. On adding acid to the alkali, the pH decreases due to the removal of alkali. Here we can see the dissociation of a constant. As the reaction is reversible here, at equilibrium, the ratio between the dissociated and undissociated particle is a constant. So here the dissociation constant, also the Ka of an acid, is given by the formula as the dissociation of a constant is equal to the concentration of hydrogen ions multiplied by the concentration of ions or conjugate base. It's divided by the concentration of an undissociated molecule. So the dissociation constant is equal to the H plus and A minus divided by the HA. Therefore also the concentration of H plus ions, we can call it as the dissociation constant is multiplied with the concentration of a acid by base. So since the H plus concentrations are very low, instead of using very small numbers, we just use the negative power of a 10 on the molarity of H plus ion. So it measured in a pH scale. So the basicity includes a convenient way to look at basicity is based on electron pair availability. The more available the electrons, thus more readily they can be donated to form a new bond to the proton, and therefore the stronger base. So here we can see that acidity and basicity are just the reverse of each other. So what are the factors comes under the both of these acid and bases will be just opposite way. So we'll come to the monoprotonic, diprotonic and triprotonic acids and bases. So monoprotonic acid which has only one hydrogen ions, example HCl, and diprotonic will be having two hydrogen ions as sulfuric acid H2SO4, and triprotonic acid has three hydrogen ions, that is H3PO4. So when it comes to the base which only accept one hydrogen ions, it's a monoprotonic base, that is sodium hydroxide, and diprotic base it accepts two hydrogen ions as a barium oxide, and diprotic acid base which accept three hydrogen ions. Acid base reaction, where when an acid and base are replaced together, they react to neutralize the acid and base properties, so producing a salt. So when acid and base reacts, it forms a salt and water. There they both neutralizes, and the H plus cations of the acid combines with the OH anion of the base to form water. So the compound formed by the cation of the base and the anion of the acid is called as salt. So an acid-base reaction is a chemical reaction that occurs between acid and a base. So several concepts that provide alternative definitions for the reaction mechanisms involved and their application is solving related problems exist. So we'll come to self-ionization of water. As the water undergoes self-ionization, means water as H2O, it gives rise to H plus and OH minus ion in an aqueous solution. As in an equation we can see the H2O gives rise H plus and OH minus, or the two molecule of H2O gives to H3O plus, that is hydronium ion plus OH minus ion in aqueous solution. So the concentration of H plus ions and OH minus ions are extremely small, so it forms a self-ionization property. So because the equilibrium lies very much on the left hand side of a reaction, means as a product it will be not in a balanced form, and the ionic product of water, as it releases H plus and OH minus according to the dissociation constant equation, we can take it as H2O here, H plus multiplied by OH minus divided by the H2O in the above expression. the value of H2O may be taken as having a constant value because the degree of ionization is too small. So here the constant is equal to the constant of a water molecule is equal to H plus and OH minus ion. So both ionization of a water will be constant values. So the constant of water is equal to the Kc, that is multiplied by water molecule, it gives rise to H plus and OH minus. Since there is a the ionization is too small. And the definition of a buffer, the buffers are compounds or mixtures of compounds that by their presence in the solution resist changes in the pH upon the addition of small quantities of acid or alkali. So what is the necessity of these buffers? As sometimes it is necessary that a solution of a definite pH be prepared and stored. So the preservation of such solution is even more difficult than its preparation. If solution comes in contact with the air, it will absorb carbon dioxide and becomes acidic. So we need, after preparing the buffers, we need to store in a certain pH. On the other hand, if solution is stored in a glass bottle, alkaline impurities from the glass may alter its pH also. So due to these reasons, pharmaceutical solutions are buffered as the buffer solutions are capable of maintaining the pH at some very constant values in a solution when even small amounts of acids or bases are added. So from these buffers we can preserve the solutions by maintaining a pH. So how we can measure the pH? It's by litmus paper, phenolphthalein and pH paper. So basically pH less than pH or greater than pH. So contains a mixture of various indicators as each type of paper measures a range of pH. So pH anywhere from 0 to 14 it will be there, and universal indicator is a mixture of several indicators, that is pH 4 to 10. So 4 to 10 will be the universal pH indicator. So this includes with the acid base 1 class of, where we saw all the what are acid base and their chemical properties of acid base and the 3 definitions of acid base. Next we'll see the further concept as acid base, the salt formation and the indicators. Thank you.